Now we will solve question number 5, which is a very easy one. The question says, if AB is parallel to CD, here is the line AB and here is the line CD. If they are parallel to each other, then angle APQ is given as 50 and PRD is given as 127 degree. Then we have to find out the value of X and Y. Now, if we look at the diagram, what do we see? That AB and CD are two parallel lines, right? Now, if we consider PQ as a transversal, right? If we say PQ is a transversal to the parallel line, then can we say that angle APQ, that is this particular angle, will be alternative to angle PQR, which is X right over here? So these two angles will be equal because they are alternative angles. So therefore we'll get the value of X as 50. So first it is given that angle APQ is equals to 50 degree and angle PRD is equals to 127 degree. Now since AB is parallel to CD and PQ being the transversal, we can write angle APQ is equals to angle APQR, right? Since internal alternative angle. Let's put the value of PQR, which will be X, and APQ, which will be 50 degree. So X will be equals to 50. Let's box it. Secondly, we have to find out the value of Y, right? Now, for the two parallel lines AB and CD, if we consider PR as our new transversal, what can we say? That angle APR, which is this particular angle, that will be equal to PRD, which is this one. So let's write it down. Since AB parallel to CD and PR being the transversal, angle APR is equal to angle PRD. This particular angle is equal to this. Now let's put the values here. Now APR, we can see it is a combination of two angles, right? 50 plus Y. Let's write it down. So APR is equal to 50 plus R, and instead of PRD, we are writing the value of the angle, which is 127. Let's solve this equation and we'll get the value of Y as 77 degree. So hence X equals to 50 degree and Y equals to 77 degree. Let's solve question number 6. Question number 6 is of utter importance because it is quite difficult and has a very important concept in it. Let's see. So the question says that PQ and RS are two mirrors placed parallel to each other. Okay, so here in the diagram we can see that PQ and RS are two mirrors. Okay, so this side where we have this dashed lines, these are the opaque surface, and this side of the mirror is the reflected one. Okay, here also for RS, this is the opaque surface and this is the reflected surface. Okay, now an incident ray AB strikes the mirror PQ at B. So here is the incident ray AB and it is striking the mirror PQ at B. Okay, then the reflected ray moves along the path BC. Now the light AB or the ray AB gets reflected along the path BC. Okay, and again strikes RS at C. It is striking the mirror RS at point C. Automatically it will get reflected, then reflects back along CD, and again it is getting reflected back along CD. So this is the path of the ray after getting reflected back twice. Okay, we have to prove that this ray AB and the ray CD are parallel to each other. This is the parallel side. Okay, now we have to prove that they are parallel. Before we begin the sum, we have to recall one very important law, which is the law of reflection. Okay, it is about the rays and the reflected angle. Okay, so what does that particular law state? It states that when a ray hits the mirror, it gets reflected, right? and the angle which it creates, that is the incident ray, will be equal to the reflected ray. Okay, before we say that, let us say Bx is the normal. I hope you understand by the word normal. Normal is nothing but a perpendicular line on the reflected surface. So Bx is the normal and Bx will be perpendicular to PQ. Okay, so this Bx is perpendicular to PQ. The angle which the normal makes with the incident ray, that means this angle, it is known as the incident angle. And the angle which the normal makes with the reflected ray, that is this one, is known as the reflected ray or reflected angle. Okay. Now, by the laws of reflection, it is stated that the incident angle is equal to the reflected angle. That means these two angles will be equal. So, if this is x, this angle will also be x. Now, in this particular scenario, we have two mirrors, right? One over here, another over here. So, since we have already discussed about this part, let's come to the other mirror. Okay. Now, RS is the second mirror and its normal is QC. Okay. The normals are not drawn in the book. We have to draw it ourselves. Okay. So, QC is the normal or the perpendicular to RS. Okay. And the incident ray for this particular mirror RS will be BC and the incident angle will be BCQ. This is the incident angle and the reflected angle will be QCD. This is the reflected angle. By laws of reflection, these two angles will be equal. Angle of incidence is equal to angle of reflection. That is, if this is Y, this will also be Y. Now, to solve the sum, let us write it down first. Okay. Now, it is given that PQ is parallel to RS, right? PQ is parallel to RS. Now, we know that let XB and QC be perpendiculars to PQ and RS. So, we have drawn XB and QC as two perpendiculars on the two mirrors. So, ultimately, it's 90 degree, right? The angle it makes as it is perpendicular. Here is what it is also making 90 degree. So, ultimately, these two will be parallel to each other, right? So, these two are parallel to each other. Therefore, XP is parallel to QC. Now, XP, since XP is parallel to QC and BC being the transversal, so what we can see is these two are parallel to each other, okay, XB and QC, and let BC be the transversal for them, okay. Then what can we say? That these two angles will be alternate to each other. If we just do not look at this part and this part, omit those sections, okay. So we have these two lines which are parallel to each other, okay. If these two lines are parallel to each other, and this is the transversal, can we say that this angle created here will be equal to this one, as because they are alternate to each other? Since they are alternate to each other, then we can say x right over here is equal to y. That is, XBC is equal to angle BCQ, right? Okay, so that's what we will write here. That is, now XP parallel to QC and BC being the transversal, angle XBC right here will be equal to BCQ. Okay, mark it as 1. Now, by laws of reflection, what can we say? Angle ABX, this angle is equal to XBC, that is this angle, and BCQ and angle BCQ here will be equal to QCD right here by laws of reflection. Okay, mark them as 2 and 3. Okay, now angle ABC is equals to ABX. Where is ABC? ABC. Okay, now what did they ask us to do? We had to prove that AB is parallel to CB. So if AB is parallel to CD, then what can we write in that case? If BC is the transversal, the full angle, this will be equal to this. These two angles must be equal, right? If these are parallel and this is the transversal, this will be alternate, or we can prove the vice versa. Okay, there's a theorem that if we can prove that two angles are alternate to each other, then those lines which are responsible for them will also be parallel. Okay, so we are going to do the same thing here. We will try to prove these two angles are equal. So let us write down A, B, C. So we have written here, now angle ABC is equals to, now from the diagram, ABC is equals to ABX plus XBC. That's what we have written here. Okay, now we can also say these two are equal, right? By equation 2, we can write these two are equal, these two angles are equal. So both will be, we can replace ABX by XBC, right? So it will be XBC plus XBC, that is equals to twice of angle XBC. Now you can also say, I may also write ABX, no problem, right? But in this case, we have this particular equation here. Okay, here we have XBC. Okay, we will try to write these are equal. Okay, for that we need this particular angle from equation 1. That's why we are writing an XBC. এইটা এই ইকুয়েশন থেকে চাই বলেই আমি এখানে XBCটাকে লিখছি, আদারওয়াইজ ABX লিখলেও কোনো প্রবলেম নেই। ওকে, so twice of XBC. Now after twice of XBC from 2, what can we do? By equation 1, we can write XBC is equals to BCQ, BCQ, twice of BCQ by equation 1. Okay, now BCQ, that is angle BCQ, twice of BCQ can be written as what? BCQ is equals to QCD. এই দুটো এক, এই দুটো যখন এক, তাহলে আমি এটাকে ভেঙে লিখি। Why? Because I want to prove ABC is equals to BCD. That's why I'm writing things according to this angle. Okay, এরকম করে আমি সাজিয়ে নিচ্ছি যাতে আমার BCD প্রুভ করতে সুবিধা হয়। There's no use of writing twice of BCD, right? BCQ. So if I break it into BCQ plus QCD, then only I can write down BCD. That's what we are doing right here. Okay, so BCQ plus QCD by equation 3, right? একটা BQC রাখলাম, একটা QCD বানিয়ে দিলাম। ওকে, নেক্সট BCQ plus QCD মানে কি হচ্ছে? অ্যাঙ্গেল BCD। Okay, so this is the equation that we have got. ABC is equals to BCD. Now for two lines, so AB and CD being straight lines and BC being the transversal, by this condition we can say that the lines AB is parallel to CD, and hence it is proved. I hope all the sums are clear to you. If you have any problem, you can definitely ask me. Please note the sums down in your copies and try to do them yourself. Okay, that's all. Thank you.